Good evening everyone. Am I audible? Good evening all. Am I audible? Good evening all. Am I audible? Yeah. Okay. So, before getting into the class, I just want to share you something. So I go through the assignments, but I told you to copy that assignment link and told you to paste it in the Google form, right? So some of you have just typed LinkedIn and Facebook instead of pasting that link. So what you have to do is that. So I'm telling this for those who are not know how to copy that link and paste it in your Google form. So this is how actually your page looks like, right? So this is the assignment. In the top left corner there is 3 dots. So if you are clicking this, here it will shows like copy link to post. Just copy this and go to your Google form and paste it here. Assignment link. If you are the same procedure is for Facebook also. If you are posted your assignment is LinkedIn or Facebook in the sense, just copy that link and paste that particular link in this column, assignment link column. Don't forget to copy that link and paste it in your Google form. So second assignment has provided 2 days before. So I will provide you the second assignment Google form link. So if you guys have done your second assignment in the sense, you can post it in the group as well as copy that link and paste it in this Google form. I will provide you the Google form link in the chat box. Make use of this. Is it clear everyone? Shall we move to the today's topic? Shall we move to the today's topic? If you are all ready or clear in the sense, just drop S in the chat box please. Let's move to the today's topic. Today's topic is SPI Communication between ESP8266 and Arduino Uno. So first, let us talk about what is SPI. So the abbreviation of SPI is Serial Peripheral Interface. So what is SPI? So SPI is a common communication protocol which is used by many different devices. So for example, you can take SD card reader modules, you can take RFID card reader modules or 2.4 GHz wireless transmitter or receivers. These are all use SPI to communicate with microcontrollers. So one unique benefit of SPI is that the fact that the data can be transferred without interruption, and also any number of bits can be sent or received in a continuous stream. In yesterday's class I have told, right? So UART is only limited to 9 bits and if any interruption has occurred, you get to know using that parity bit. But coming to SPI, you can transfer the data without interruption, and also you can send any number of bits and you can receive any number of bits and in a continuous stream. So with I2C and UART, data is sent in packets that is limited to a specific number of bits. And start and stop condition define the beginning and end of each packet. So the data is interrupted. Maybe it get interrupted during transmission. So with whatever the devices which are communicating via SPI are in a master-slave relationship. So here it is a master, here it is a slave. So the master is what? This is the controlling device. It can usually a microcontroller. So while the slave can be a sensor, a slave can be a display, or it can be a memory chip, but usually master is a microcontroller. So this is the controlling device while the slave takes instruction from the master. So the simplest configuration of SPI is a single master, single slave system, but one master can control more than one slave. So here what does the master and slave consist of? MOSI, MISO, SEL, SS, which is MOSI means master out, slave in. So this is the line for the master to send data to the slave. So that's why master out, slave in. And this is MISO, master input, slave output. This line is for the slave to send data to the master. So this is SCLK, which is clock. This is the line for the clock signal. And this is the chip select or slave select. So this is the line for the master to select which slave to send data to. Master can choose to which slave master want to send data. So now let's see how actually SPI works. So first, so here it is the single master and multi-slave. So first the clock. So the clock signal synchronizes the output of data bits from the master to the sampling bits by the slave. So one bit of data is transferred in each clock cycle. So the speed of the data transfer is determined by the frequency of the clock signal. So SPI communication is always initiated by the master, since the master configures and generates the clock signal. So the control is in master's hand. The clock signal's control is in master's hand. So any communication protocol where devices share a clock signal is known as synchronous. There is two types. One is synchronous and another one is asynchronous. SPI comes under synchronous because it uses clock signal. If you are taking UART in the sense, it doesn't need a clock signal, so that is asynchronous. So SPI is a synchronous communication protocol. There are also asynchronous method that don't use a clock signal. So for example, in UART communication, both sides are set to a pre-configured baud rate that indicates the speed and timing of the data transmission, right? So SPI is synchronous, which needs clock signal. And then coming to slave select. So the master can choose which slave it wants to talk to by setting the slave line, which is chip select or slave select line, to a low voltage level. So in the ideal, which means in the non-transmitting state, the slave select line is kept at high voltage level. So multiple chip select pins may be available on the master, which allows for multiple slaves to be wired in parallel like this. So if only one chip select pin is present, multiple slaves can be wired to a master by daisy chaining. Now let's see. multiple slaves. So SPI can be set up to operate with a single master and a single slave, and it can be set up with multiple slaves controlled by a single master. But here you can't use multiple master. You can only use single master, multiple slave. So there are two ways to connect multiple slaves to the master. If the master has multiple slave select pin, the slaves can be wired in parallel form. So if only one slave select pin is available, in the sense the slave can be daisy chained. And fourth one is Mosey and Meso. So the master sends data to the slave bit by bit in serial through the Mosey line. So the slave receives the data sent from the master at the Mosey pin. So the data sent from the master to the slave is usually sent with most significant bit first, which is MSB. The slave can also send back to the master through the Meso line in serial form. So the data sent from the slave back to the master is usually sent with the least significant bit, which is LSB. So now let's see clear about how it actually send and receive the data. So the first step is the master outputs the clock signal first. So this line, using clock signal line, the master outputs the clock signal first to the slave. Then the master switches the chip select pin to a low voltage state, which activates the slave. By default, slave is in high voltage level. To turn it on, the master sends a low voltage state to slave. And the third step is the master sends data one bit at a time to the slave along Mosey line. The slave reads the bit as they are received. And next step is, if a response is needed, the slave return data one bit at a time to the master along Meso line. So the master reads the bit as they received. This is how actually SPI works. Is it clear, everyone? Is it clear what is SPI and how it actually works? Is it clear? Do you have any doubts regarding this lesson? You can ask me. If it is clear in the sense, let's move to the next slide. Is it clear, everyone? Then advantages and disadvantages of SPI. So coming to advantages, there is no start bit and stop bit. So the data can be streamed continuously without interruption, right? And there is no complicated slave addressing system like I2C. You will get to know in I2C topic. Like I2C, SPI doesn't need the complicated slave addressing system. It is higher data transfer rate than I2C. If you are compared to I2C, SPI has higher data transfer. And there is a separate line for Meso and Mosey. So data can be sent and received at a time. And coming to disadvantages, it uses 4 wires. In you are taking UART or I2C, it requires only 2 wires. But coming to SPI, it requires 4 wires and no acknowledgement that the data has been successfully received or not. In UART and I2C, the data is sent in packet. So in UART, you can get to know using parity bit, likewise in I2C. But SPI doesn't have any packet. So there is no acknowledgement that your data has been successfully sent or not. And no form of error checking like the parity bit in the UART. And also it only support one master, which means single master and multi-slave. It doesn't support multiple master and multiple slave. So these are the drawbacks in SPI communication. So next we can move to coding part. So as like in UART, we have to code simultaneously for Arduino Uno and ESP8266. Here we are going to code. We are going to make ESP8266 as a master, and we are going to make Arduino Uno as a slave. So the master is going to send data to the slave, and the slave is going to receive the data from the master. This is what we are going to do. So note that ESP8266 is a master and Arduino Uno is a slave. Our master is going to send data to the slave, and our slave is going to receive that data. So let us write the code first. So open your Arduino IDE, new sketch. Few minutes. Okay, first let us write the code for master. So here is Arduino Uno. Let me select the port as well, component 12. Here ESP8266 component port is COM4. So first let us write the code for master, which is ESP8266, right? So first what we have to do is that we have to include SPI library first. SPI .h library, and then so this line includes SPI library, which provides functions for using the serial peripheral interface communication protocol. And then I am going to create char buff. Here I am going to print what I am going to send. So I am going to just send a message like hello slave. So this line declares and initializes a character array named buffer with the message hello slave. This array will be transferred over SPI to the slave device. So then void setup function. So inside what we have to do is that first we have to mention bonded for communication purpose, right? So serial dot begin. Inside I am going to give 9600. Then we need to start SPI dot begin. Sorry. So it initializes the SPI communication using SPI dot begin function. This steps up the SPI bus and prepares the Arduino as the master devices for SPI communication. So then we can move for while loop function. So inside while loop, first I am going to create a for loop to iterate over each character in the buffer array. So for inside I am going to just give integer I is equal to 0 and I lesser than size of buffer and increment, which is I plus plus. So inside I am going to give SPI dot transfer buffer of I. So inside the loop, it transfer each character using buffer of I over SPI to the slave device using SPI dot transfer of buffer I function. So this sends one character at a time over the SPI bus. Then we have to add a delay for 1 second, just 1000 millisecond. So after sending the complete buffer array, it adds a delay of 1 second using delay of 1000. This then the loop repeats, sending the buffer array again after the delay, creating a continuous loop of different data transfer over SPI. This is what it happens. So this is all about our master code. Now we have to jump for slave code, which is our Arduino Uno. 1 minute. So let me verify it first. Let us wait for a few seconds to verify this code. So have you all tried the second assignment? Have you all finished? I just gave you time for 2 days, right? So today is Friday, 12th day. Have you finished your assignment? So please just try to submit your assignment before Sunday. So Monday you will get your third assignment. So before that, try to submit your assignment all, please. So okay, let us write the slave code, then we will wait for this. So here slave, which is Arduino, right? So first the the same thing. We have to include library. SPI.h library. Then I am going to create a character buffer array. Like we can just give 100. So this line declares a character array named buffer with a size of 100. So this array will be used to store the received data over SPI. So then I am going to make volatile byte index, and then again volatile boolean, which is a bool, receive done. Done. So these two lines, volatile byte index and volatile boolean receive done, this two line declares volatile variable index which keeps track of the current index in the buffer array, and receive done a flag indicating whether a complete message has been received or not. Now we can move for void setup function. So void setup, instead I am going to give void. So inside void, as usual, serial dot begin 9600. You should give the same baud rate for both sides, and then SPE. So it enables the communication. This line SPC or bit SPE, this line enables the SPI communication by setting the SPE, which is SPI enable, bit of the SPCR, which is SPI controlled register. SPCR is controlled register. So then what I am going to do is that I am going to define pin mode of, I am going to set NISO as output. So it set the MISO pin as an output pin using pin mode MISO and output function. So this pin is used for data transfer from the slave device to the master device in SPI communication. So then I am going to initialize index as 0, and I am going to make receive done as I am going to give false. And now SPI dot attach interrupt. So after that it initializes the index variable to 0 and sets the receive flag to false. Finally it attaches the SPI interrupt using SPI attach interrupt pin, so which allows the code to respond to the SPI events. So this is all about void setup function. Now void loop function, again I am going to give void. Nimisha Chitriv, your second assignment was you can do any interface between day 6 to day 10. We have interface 5 things: DHT sensor, ultrasonic sensor, Bluetooth module, and soil moisturization monitoring. And we have done one more interface, which is I think event management system. So you can do any one interface from day 6 to day 10. This is your second assignment. Gaming block. You are asking about which output? I don't actually get what you are asking. You are talking about which output? So inside void loop, first I am going to make a if condition. It checks if the receive done flag is true, indicating that a complete message that I have been receiving or not. For that, if receive done, then inside what we have to do is that buffer of index which is equal to 0. So if a complete message is received, it has a null terminator. So buffer of index is equal to 0 to mark the end of the received data in the buffer array. So now we have to print that received data, right? So serial dot println, inside I am going to print that received data on the serial monitor. So now again I am going to make initialize index as 0. So receive done as false. Yeah. This is about void loop function. Now what we have to do is that we have to add interrupt function. ISR, interrupt service routine. So inside I am going to give SPI STC. Sorry. Wait. So this line defines an interrupt service routine, which is ISR, for the SPI STC, which is nothing but SPI STC, serial transfer complete interrupt vector. So this ISR is triggered when a full SPI transaction is completed. So inside what we are going to give is that unsigned integer, S register, static register, so this line save the value of the S register status register in the variable old SRG and disables interrupts using CLI. This is done by ensure the ISR executes automatically without being interrupted by other interrupts. So next we have to give character C. Here I am going to SPDR. So this line reads the received data from the SPI data register and stores it in the variable C, and the SPDR holds the data received during the SPI transaction. So then I am going to make another if condition, index lesser than size of buffer. So this code block checks if the index is less than the size of the buffer array. If it is, it means there is a space available in the array to store the received character in the sense. Inside what I am going to give is that buffer of index increment is equal to C. The received data is now stored in C, right? So inside the block it stored the received character C into the buffer array at the current index position using buffer of index increment. So it also increment index after storing the character. So now inside this another if condition. So here C equal to null character. Receive done. I am making it as true now. So next it checks if the received character is a new line character. If it is, it sets the received done flag to true, indicating that a complete message has been received. So after that I am going to make status register equal to OLD SRG. So this line restores the value of the status register to its original state and allowing interrupts to be enabled again. So the ISR ends and the program continues execution from where it was interrupted. So this is about the interrupt function. Let me verify it first. Okay, here our code is error free. 1 minute. Sometimes your ID doesn't work properly. Just copy this and paste it in the new page. Now let's cancel this or minimize this. Here we have to select, this is SPI 266 program, right? So go to your board and select 12E and select the correct port, which is, sorry, this is not Arduino Uno, this is 12E, and our port was component 4. Here it is 12 and here it is 4. Yeah, right. So now let me verify it here. Let me check once again the port correctly. Yeah, we have correct to select the correct port. Okay. Now let me upload. So here the hardware. Okay. Is it clear? Is it visible? Okay, let it be. So this is our Arduino Uno. This is our ESP8266. So the pin configurations are here. You have to take the SPI pins, which is 13, 12, 11 and 10. So your 13th pin is clock pin and your 12th pin is meso pin, 11th pin is MOSI pin and 10th pin is chip select pin. As well as if you are taking ESP8266 in the sense, here your clock pin is D5, meso pin is D6, MOSI pin is D7 and chip select pin is D8. So you have to connect the ground to ground common from this controller to this, and you have to connect the clock from here to this clock, and you have to connect MOSI to MOSI, meso to meso and chip select to chip select. This is what your connections looks like. So now let us upload the code. So first I am going to upload the master code, which is ESP8266. If you upload the code, in the sense the LED will blink here. It's uploading. Let's wait for a few minutes to uploading. Let us wait for a few minutes. It's uploading now. A code has been uploaded. So now let's upload the code to Arduino Uno, which is slave board. Yeah, it's uploading. You have to wait until it fully get uploaded. Second, let me upload it again. Let me unplug the Arduino controller's USB and let me connect it again. Tenth day attendance link was already posted, Deepak. Just go and check it once again. I think there is some issues with my USB cable, so you don't have to waste time. I will show you the output, right? So after uploading the code, your output will be look like this. So if you type hello slave from your master code, in the sense your slave will receive that message and print it in the serial monitor here. It will print like hello slave. So whatever you are sending in the master slave, using master slave you can send whatever you want. Your slave was supposed to receive that message and store it in the serial port. So let me show you one video. Yeah. So here we don't have to type anything because we have already given the code, right? Like hello slave, right? So in UART you can send whatever you want. In SPI also, if you want to send, in the sense you can modify the code according to your need. So here we have already mentioned what is the message the slave had to receive in the code itself. So it will receive the message and print it in the serial monitor like this. So okay, this is all about today's session. If you guys have any doubts related today's topic, in the sense you can ask me. If it is clear in the sense, let us wind it up here. Is it clear, everyone? Is it clear what is SPI, how it actually works, how to write code for master and slave, how to get output from that? Is it clear, everyone? If you have any doubt regarding this, then you can ask me. If everything was clear in the sense, let's wind it up from here. So let's catch up in tomorrow's class with another topic. Is it clear? Everyone, is it clear or not? Okay. Thank you all. Let's catch up in tomorrow's class with next topic. Thank you, everyone.